As we approach T-minus 25 minutes, we're going to stand by for a situational briefing from the launch director, Clay Walker, in Mission Control. Let's listen in. Just joining us, we are just under T-minus 24 minutes, and we're currently waiting for an update from Mission Control. And I do have an update here from Mission Control. We did just get an updated tea time from the range of 1400 Eastern. Again, that's 1400 Eastern. That'll be reflected shortly on the tea clock. There you go. We are now 1 hour away from our launch. Our hold and extension of our tea clock is due to us wanting to get more time for propellant conditioning. We're going to stand by to hear more from Mission Control, but as of now, we are launching at 1400 Eastern. And you see the T clock is no longer paused now. We are counting down. We are at now T minus 58 minutes and 18 seconds. For those just joining us, we are at T minus 49 minutes. As a reminder, we set back the T clock to allow us more time for propellant conditioning. In the meantime, why don't we talk about Stage 2 MDC?
Great idea. One of the approaches we take here at Relativity is to be focused on having a lot of hardware that we can test in order to reduce our risk getting into flight. One attempt that we tried to do that was paved out through successful testing was Stage 2 hot fire testing. This is where we took Stage 2 to NASA Stennis and we integrated the Aeon vacuum engine with a stub nozzle. For this test, we filled the tanks with our cryogenic propellant, and this is also where we were able to fire the engine and see interactions between the engine as well as the stage. What's really important about this type of testing is that it allows us to reduce risk. It allows us to test our propellant estimation algorithms. It also allows us to test how we pressurize our tanks. We got so much learnings from these tests, and why don't we take a look at that journey to Stage 2 hot fire testing.
My name is Zach Rubin. I'm the second stage RE. We're here. We have the flight engine on the flight stage, and we are going to do a full mission simulation starting with terminal count through Stage 1 burn and Stage 2 burn. Obviously, Stage 2 burn is going to be the main event, and if it all goes well, we'll accept it for flight.
5, 4, 3, 2, 1, 0.
attempt at our actual mission duty for the flight vehicle. It was the first attempt. We went full duration on the first try. It was really cool to see all the teams finally come together. Avionics, flight software, ground software, prop, fluids, stage and ground systems. Really cool to be a part of.
As we continue to wait, can we get a brief update on the mission going on today?
Yes, so we are a little bit less than about 50 minutes until launch. We are still we took it back to be able to condition our propellant, so we're still doing that at the moment. But the range is green and the weather is looking great.
We are still moving forward, team. As we continue to wait, we just saw a video about Stage 2 mission duty cycle testing. We reached that full mission duty cycle duration for Stage 2. Similar to Stage 2, for Stage 1, we also completed stage hot fire testing. However, that was here at Launch Complex 16 instead of at NASA Stennis. We actually utilized our launch pad and adapted it to also have the capability to do Stage 1 hot fire testing. Let's take a look at this video.
Hello, I'm Pat Svatek. I'm the Cape Operations and Launch Site Director for Relativity here at Launch Complex 16.
Clay Walker, I'm the Director of Test Operations.
The objective for the test campaign for Stage 1 was to ensure that what we designed and built was going to be functional as intended.
A spin start is the least risky way to start the system and validate the timing for actual full combustion.
Specific points that we were looking to see in the spin start campaign was to make sure that we had the timing sequences correct.
It's pretty similar to any industry standard that you would expect. Very thorough and very impressive.
We chose to do our Stage 1 hot fire campaign at the actual launch site.
What we're hoping to look for is that the system responds appropriately. The engines feed the stage pressurization systems, and then the pressurization systems feed the propellant feed systems for the engine. They all have to be able to rely on each other, and that's what we're looking for.
It's all about testing the fully integrated system, all 9 engines on Stage 1 together, to validate the individual stage is ready to go into the full-blown campaign for static fire and launch.
Ultimately, what we look for in acceptance testing is, do we have enough data to confidently say that we're going to be able to hit our flight objectives? We got the system health verification that we're looking for. It's been almost 3 years working on this program, and to actually see the completed hardware standing on the pad, it's very exciting.
I'm very proud of the entire Relativity team. Quite frankly, it takes everyone across the company to be successful, and we had a bunch of folks across the company, from engineers, technicians, and support services across, to help us out and make sure that we were successful.
If you're just joining us, we are just under T minus 33 minutes. We are progressing well towards our launch time of 1400 Eastern. If you missed the delay, the hour push was due to propellant conditioning. We wanted to get more time to continue that operation, and we're currently doing a great job. Everything is still green and a go for that launch time.
That is great to hear. I am so stoked to keep moving forward. As we continue to wait, maybe let's take a moment to recognize the technicians that helped us build the rocket that you see on the pad today. We wouldn't be where we are today without all of their hard work and effort to build this rocket. Let's take a look at this video.
Something that makes Relativity and all of its technicians unique is that we all come from very different backgrounds.
I was a freelance 3D animator. I also was working on motorcycles. I was working on guitar parts. So lots of hands-on actual manufacturing and fabrication. So this was really like a whirlwind of all the things that interest me.
Prior to joining Relativity, I was a teacher and a football coach. And I made sure that our kids were preparing for college and doing study halls, and they turned the tables on me. I had the passion to do it. It was something I wanted to do. It was something I wanted to make that career change and get into.
I was previously in the Navy for 5 years, worked on helicopters, built engines and rotary. And then that led me into the aerospace world, and there I built other rocket engines and pretty cool stuff, and that eventually led me here, which was very relatable to what I've done in the past. And it's pretty cool being part of a company in the earlier stages.
So I think my career really first started when I went to school at Cal Poly SLO. I went into my first manufacturing class, Machining 101, and the teacher in that class saw that I was really interested in using my hands to make things, and I really knew that that was my passion because I dived in deep with it.
At first, my favorite part was robots, lasers, and, you know, computer programs. So now I can say it's the people. I love the people here. Everyone, all the new hires, all the people that I met coming in, everyone is genuinely excited to be here.
One of the great things about here is attention to detail. We have to be meticulous about the things that we do because, you know, these little measurements are going to carry on to affect other things that are carry on to affect something else. The importance of it is never lost on me, and that's exciting.
Me as a technician and the experience that I've gotten throughout the years, I'm able to bring it here to Relativity. And working with the other engineers and the other technicians, we like to collaborate and bring those ideas together, and it's exciting to know that our input is worthy here, and so it can go far further, so it's pretty exciting.
I think the coolest part of my job is that right now I'm getting to help design the machine shop for our next headquarters, and so that's not just copying the machine shop that we have now, that's thinking 5-10 years into the future and thinking, what are we going to need and how can we improve what we have now and how can we really spend the time planning this out. And so I have direct control over what that's going to be like, and I think that's amazing.
you can see, we have placed another hold on the T clock at T minus 24 minutes. We do need additional time for propellant conditioning. We're going to stand by for additional updates, and I'll send that to you as soon as I have them. Are currently holding the clock and taking it back once more. We just coordinated for a new T0 time with the range. Our new T0 time is now 14:40 Eastern. That is 2:40 p.m. Eastern. We're going to allow a little bit more time for propellant conditioning. As some of you may know, this is not at all unusual for a first launch. This is perfectly expected since we want For a first launch, this is perfectly expected since we want all systems to be as perfect as possible before we do this. If you're just joining us, we are now back at T minus 38 minutes. We did set back the clock and coordinated with the range for a new T0 time of 1440 Eastern. That is 2:40 p.m. Eastern. We did add this time to allow us to continue our propellant conditioning. We'll continue to provide you updates as we get them. If you're just joining us, we are currently at T minus 23 minutes. If you recall, we did set the T clock back a little bit in order to allow for propellant conditioning. You might also be able to see that the clouds are coming in. Our team is keeping a close eye on the weather right now just because we want the maximum visibility that we can get for this historic first launch. We'll keep you updated along the way. We're going to stand by for a situational briefing from the launch director, Clay Walker, in Mission Control. Let's listen in for the next few minutes. I'm hearing now that we're expecting the go, no-go polls to occur in approximately 3 minutes. While we wait, let's talk about the nose cone that we have today.
So we don't have a customer payload on board, but we do have a memento inside of our nose cone. we have included our first ever 3D printed piece from our Stargate printer. And of course, it was a failed print since no one had ever done it before. As you see on your screen, that is our nose cone memento. That piece is 6.5 inches in diameter and weighs about 3 pounds. It is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with GLHF, good luck, have fun, and our mitosis logo to commemorate this maiden launch.
From our very first failed print 7 years ago, Relativity's team relentlessly overcame thousands of challenges against all odds to get to today, our first 3D printed rocket launch. Like the first print, Terran 1 is the first step of many towards making humanity a multi-planetary species. As a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Terran R, our larger medium to heavy lift reusable launch vehicle. In just a few minutes, the launch director is going to poll the teams for launch, so let's listen in.
Yeah, go. FTS.
FTS go.
FTS go. RF.
RF go.
RF go. GNC.
GNC go.
GNC go. Flight software.
Flight software go.
Flight software go. Prop 1.
Prop 1 go.
Prop 1 go. Prop 2.
Prop 2 go.
Prop 2 go. Fluids 1.
Fluids 1 go.
Fluids 1 go. Fluids 2.
Fluids 2 go.
Fluids 2 go. Loads.
Loads go.
Loads go. Rock. Ranges go. OSM.
OSMs go.
OSMs go. RC. RC go. Vehicle.
Vehicles go.
Vehicles go. CE.
CEs go.
Cs go. LC.
LC go.
All parties have reported go for launch countdown. Once the T-clock begins, anyone can call for a hold at any time. If a hold is called prior to T-minus 70 seconds, the T-clock will continue to roll until T-minus 70 seconds, at which point a hold will be automatically initiated. A hold is not possible after T-minus 70 seconds, and any hold call after that time will result in a terminal count abort. Should a hold or manual abort be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that the OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and the RC on the primary net.
LCCE on Bravo, can we open stage 1 fuel bleeds, please?
Copy. Opening stage 1 fuel bleeds.
GCVC, please limit comms channels to Alpha, Bravo, Charlie, and countdown unless directed by LC or LD.
Support room, this is vehicle on LV.
You just heard our launch director complete the go, no-go polling with our mission control team. All systems, as you heard, are currently healthy, so as of now, we're able to proceed with our scheduled launch time in about 12 minutes.
Throughout today's live stream, you've been hearing callouts for mission control. Let's take a moment to introduce you to our mission control team. Clay Walker, launch director. John Wiswall, launch conductor. James Harris, chief engineer. Elijah Escobedo and Zoe Dickert on vehicle controls. Brian Batters, ground control. Bill Stack, ground. Joy Mosdell, range control. There are a few notable members of leadership supporting today's launch who are also here at Launch Control. This includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of Cape Operations, Pat Svatek. These are among many, many others who are making today's launch happen. For those of you that are just tuning in, you can see Terran 1 on the pad. This rocket is 85% 3D printed by mass. It is 110 feet tall and 7.5 feet in diameter. Stage 1 has 9 Aeon 1 engines, and our second stage has an Aeon vacuum engine. These engines are also 3D printed using powder bed fusion. We're going to go ahead and take a moment to pause and stay tuned as we wait on the launch countdown.
We are getting extremely close here. Our countdown sequence will begin in T-minus 10 minutes, so just 30 seconds away.
T-minus 10 minutes, countdown sequence has started.
We're currently at T-minus 9 minutes and 40 seconds. In the upcoming minutes, you're going to hear several call-outs from Mission Control as we go through the final pre-launch procedural steps, including the priming of the igniters, final engine checkouts, transporter erector retraction, and getting that final go for launch. Again, we're now pressing the tanks to flight pressures, and we're currently proceeding with our scheduled launch time. We'll be looking for a call out in the next 30 seconds that stage 1 is transitioning to helium.
Stage 1 pneumatics have transitioned to helium.
There you go. That means we're pressurizing the propellant tanks to flight
Tanks are pressing
pressures.
for engine chill.
We'll be charging the Stage 2 igniters to flight targets in just about 10 seconds.
We are now getting into the business end of today's countdown.
Pressing Stage 2 igniters to flight target.
Arwa, let's go ahead and walk through the launch timeline.
Yeah, sure. At T-minus 3 minutes, the transporter erector will retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will be on internal power. At T-minus 70 seconds, the vehicle will go into terminal count. This is again when the vehicle's internal flight computer takes control of the countdown. We then go into final flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operation safety manager. At T-minus 6 seconds, we'll have ignition of those 9 beautiful 3D printed AON-1 engines, so you'll see the flames beneath the rocket at that point. And at T0, we will have liftoff. Shortly after that, at T plus 2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly vertical. At T plus 12 seconds, we'll begin our pitch over program, and at T plus 80 seconds is that important milestone of max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we'll have main engine cutoff, or MECO, where the Stage 1 engines will shut off, followed shortly by stage separation and the AON vacuum engine igniting. Second stage will burn for a little under 5 minutes. And then at approximately T plus 463 seconds, we'll have second engine cutoff, or SECO. As a reminder, we do not have a fairing or any payload deployments for this first launch. With that, we'll go ahead and wait and stay tuned with Mission Control.
And once again, we are so honored to be hosting this launch with you all today. I'm Arwa Tizani-Kelly, Technical Program Manager for Test and Launch at Relativity Space.
And I'm Rachelle Aniceto, Chief of Staff for the Vehicle Architecture and Technology team.
And we are now less than 5 minutes away from watching the world's first 3D printed rocket launch.
Stage 1 igniters priming in.
We're currently priming the igniters with gaseous oxygen and gaseous hydrogen. Our ignition system uses these propellants flowing across a glow plug.
Stage 2 is on internal power.
And you just saw the transporter erector cradle disengage.
The cradle's disengaged.
There we go. The cradle arm slowly started releasing Stage 2 at the top there so that the strong back can retract, and we confirm that Stage 2 is now on internal power.
Stage 1 is on internal power. Stage 1 TVC checkout complete.
We just completed Stage 1 TVC checkouts. That means that we performed the final thrust vector control health checks on both stages before liftoff. We'll be doing Stage 2, or rather completing Stage 2, within the next 10 seconds.
Stage 2 TVC checkouts.
Next up, we'll be retracting the strong back, and then our range coordinator will ask the range for their status one last time.
Rock, report range status.
Range green.
And that was confirmation that the range is green for launch. We are almost a minute away.
Announcement on countdown net. This is the LD. We are holding at T-minus 70 seconds prior to terminal count to address issue.
All right, you heard Clay Walker, our launch director there. We are holding at T-minus
back retracting.
69 seconds to address an issue. We are, however, at the same time retracting our strong back. That black truss structure there is the strong back. It'll retract just a few degrees to prepare for umbilical separation. We'll stand by for further updates from Mission Control, and we'll update you on the hold. As a reminder of what our launch director said earlier, this is the last opportunity that our team can call a hold. So the team chose to take that option at T-minus 70 seconds and ensure everything is nominal before we go into our terminal count sequence. Again, what you're looking at in front of you is 85% 3D printed, and it is about to fly. Those white clouds you see coming out of the rocket are due to the venting of the chilled gas from the rocket into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds. I'm hearing that our T-clock will resume in about 1 minute.
Announcement on countdown. This is the LD. The T-clock will resume in approximately 20 seconds. Transitioning to terminal count.
As a reminder, from here on out, when the T-clock resumes, our countdown sequence will be automated and controlled by the internal flight computer. We are extending the hold just a little bit longer. We're going to stand by for further updates from Mission Control.
Announcement on countdown net. This is LD. We have had a terminal count aboard, saving the vehicle and assessing recycle options.
You heard that announcement from our launch director. We're going to have an update momentarily as to what happened with our automated abort. If you're just joining us, we did have an automated abort at T-minus 70 seconds. The team is currently assessing if we're able to recycle since we are still within our launch window. So we'll provide that update as soon as we have confirmation from Mission Control. Once again, we had an automated abort at T-minus 70 seconds. Our launch director and our teams in mission control are currently assessing the recycle options that we have for today since we're currently still within our launch window. We're standing by to hear that update from Clay Walker. All right, I just received confirmation that we are going to recycle, and we have an updated T0 time of 15:55 Eastern. So again, that's 15:55 Eastern, approximately 45 minutes from now. We're going to keep going. To provide an update on the cause of the previous automated abort, the stage 2 oxygen temperatures were out of limits, so that's why we had that abort at T minus 70 seconds. Now we're going to resolve this issue and continue on with our recycled and new T0 time of 15:55 Eastern. Quick update here that our updated launch time that's been confirmed with the range is at 15:45 Eastern. That is 3:45 p.m. Eastern. The T clock at the top of your screen is accurate and will keep you up to date as to when we are going to lift off. everyone. We are currently at T minus 23 minutes and 56 seconds. We're currently waiting for an update from Mission Control. Let's continue listening in and stand by.
Announcement on Countdown Net, this is the LD. All parties, we are scrubbing operations for the day. Thanks for playing.
All right, you just heard that update from Mission Control. We are unfortunately scrubbing today's operations. We're going to stand by for additional details from Clay Walker. unfortunately, we just got word from the launch teams. We're scrubbing for today's launch temp due to A. Remove that and put in her first. As you saw, we unfortunately scrubbed for today. But while we obviously had high hopes for sending our Terran 1 off today, we're